In this video, we're going to show you how to generate toolpaths to cut out the three-legged stool assembly. The vectors for this were edited in another tutorial, and starting with that file, initially we're just going to calculate a simple profile toolpath and show you how quick and easy that is. Then moving further on into this example, we're going to show you how you can get a lot more control over the cutting if you want. For instance, we'll show you how in some areas it may be more beneficial to pocket rather than profile, and then we'll show you a lot more of the options that you've got within the profiling to address things like start point position, how the tool leads in on the job, and some of the other things you can do to really gain a great deal of control over exactly how your part's going to be machined. Let's go ahead and open a new copy of the software. So let's come over and click on the icon to open an existing file, and from the project folder for the three-legged stool we're going to select the file three-legged stool vectors and hit open. Now we can see the vectors that were edited during the drawing part of this tutorial. So let's go straight over to the Toolpaths tab. So I'm going to click on the icon here, and that will close the Design tab on the left, open the Toolpaths tab on the right. The first thing we always need to do before we calculate anything is to check our material and make sure that matches the setup on our machine. To do that, we come up to the material setup area and click on the Set button. Now for our particular job, we're going to imagine that we're cutting this out of a sheet of 3/4 inch thick plywood. And we're going to assume that it's exactly 3/4 inch thick. And the part's been set up in order to match that. So these pieces here, which different parts of the material are going to need to slot into, have been designed to already be exactly 3/4 inch across. Now if your material thickness was slightly different to that, you would need to adjust the design in order to accommodate it and make sure that you change the values. And as with anything in here, if you are planning to cut this, not only do you need to check that the material values and the drawing are correct for those, but you also need to make sure that the toolpath parameters and settings are safe and appropriate for your particular machine and the tooling that you have available. So if we check our material thickness here, we can see that's already set to 0.75 or 3/4 inch, so that is actually correct. Next we're going to think about the Z0 datum. So at the moment it's set to the top of the block, but if you're cutting parts out like we are here, it can be beneficial to set it to the bottom of the block. So if I click that option here, you can see that'll change. It's indicating Z0 on the bottom of the block, or another way to think of that is Z0 is now on the top surface of the table of your machine or your sacrifice sheet. That means that when we do the cutout and it sends the tool to Z0, then it should be very precise in going to that depth rather than referencing that depth from the top of the material where we may have a difference in material thickness across the part which will add inaccuracies in. So here I'm happy with that. I've set Z0 to the bottom. The XY datum is in the lower left, which is indicated here on the diagram and also on the actual 2D view itself by this red square. The rapid gaps are appropriate in this case, and the home start position is actually a little low, and we'll see that by, if I hit the OK button, the software will warn me that the home position is below the thickness of the material. Remember, we've set Z0 off the bottom of the block, so that home position needs to be more than 3/4 inch in order to be above our block of material. So I'm going to hit OK. The software will have automatically set that to a value which is appropriate, but if we hit the set button again, we can go back in and double check that, and if we want to, we can type in our own value. So in this case we'll put x0, y0, z equals 1 and go ahead and hit OK. Now I want to profile around all the parts in the job, so a quick way to select all the vectors in the job is either to come up to Edit and select all vectors, or you can see there's a shortcut which is Control A. So I could just go into the 2D view here, hold down the Control button, hit A on the keyboard, and you can see all the vectors get selected. Now I'm going to come over and click on the Profile Toolpath icon. Now at the moment we have the short version of the form showing, and that's because we don't have this box checked here. When we check that, it will show advanced toolpath options. So if we do that now, you can see we get a longer version of the form that has more options on it, and we will need some of these options in this particular tutorial. So with that checked, we're going to come to the top of the form here, and we have the start depth and the cut depth. Now these are not absolute values, so they're effectively always going to be measured relative to the material because they're depths from the top of the material. So even though we've set our Z0 to be up at the bottom of the block, once we get into the cutting depths themselves, these are just relative values to the material. So start depth is going to be 0, and then the cut depth is going to be all the way through the material. Now we can either type that value in, or a quick way to reference whatever the thickness of our block is if we're cutting the part out is to type Z equals, and that will just pick up that value for us. So we don't need to remember what it was. Next I'm going to come down and choose the tool we want to cut this out with from the tool database. So I'm going to click on the select button, and in here I'm going to choose the 1/4 inch end mill. Now I can either make permanent edits to the tool in the tool database by editing values here and hitting apply, or if I just want to make edits to this tool for this one particular toolpath, then the way I do it is to hit OK and then to click on the edit button here, and now I can just change the parameters for this particular toolpath without overwriting the values that I've got saved in the tool database. So here I'm going to change my pass depth to be 0.25 of an inch, and I'm going to come down and adjust some of the settings for the speeds and feeds, and again you just need to make sure these are appropriate for your machine and the material you're cutting. If I'm happy with that, I can hit OK, and the software shows me it's going to cut this in 3 passes, and each one of those will be 0.25 of an inch thick. And we'll come back in a moment and revisit some of this when we make some edits to this toolpath. Coming down, I want to cut outside my vectors here, so I want to go outside the lines, and the software knows automatically to go outside the first vector it gets to, and then if it finds other vectors inside a shape, it knows to cut inside those, and so on and so forth. So if there were vectors within vectors within vectors, the software would know to swap from outside to inside to outside to inside, so that it's always cutting on the right side of the vector, dependent upon what choice you make here. Now we have the choice of whether to do climb or conventional milling, and then coming further down from there we've got this allowance offset function. This allows us to overcut the shapes or undercut the shapes by an amount. Now when we're making a part like we've got here that we're actually looking to slot together, you can use this allowance offset to build in a small gap that will make the assembly easier. At the moment everything's been drawn exactly to size, so if we cut this with no allowance, it's actually going to be very difficult for us to slot it together. So what I'm typically going to want, if I've drawn the design like I have here, is to put in an allowance, a negative allowance in this case, so that the parts will actually be undercut a little bit, they'll actually be a little bit smaller. So if I put in negative 0.02 of an inch, then everything's going to be undersized by 0.02 of an inch on each side. So in effect, everything will get undersized by 0.04 of an inch. And you just adjust that value to be appropriate to what you are doing. Sometimes it can be valuable to actually cut test parts just to see what an appropriate value is for your particular setup. And I'll show you how this affects the cut in a moment when we calculate it. And at this stage now I'm just going to ignore all the other options here. I will come back to revisit some of these in a moment. I'm going to come down to the bottom and we'll just call this profile cutout and hit calculate with the parameters that we've set up there. Now the software, when we calculate a toolpath, will automatically bring us into the 3D view, and it will open the preview toolpath form here. Preview toolpath form is going to allow us to visualize this toolpath in a 3-dimensional area. So if I click with the mouse in the window and then move the mouse around while holding the left mouse key down, you can see I can rotate this 3D visualization of our sheet of material. So if we come over into the preview toolpath form, I can just hit preview selected toolpath there if I want, and that will just quickly run through and show me the finished result. Now if I want, I could slow that down, so I could say reset preview, and as long as I've got animate preview and draw tool switched on here, then I can use this slider to control the speed. So I could slow that down there, and then I could hit the play button, and you can see that's just going to go through and work along the toolpaths a little bit slower so that I can actually see its progress and the order that things are going to be cut in. And that can be quite useful, particularly when I'm doing a part like this. Now the 3D view is very useful for me. I can see what the part looks like there, but we also have the ability to preview toolpaths in the 2D view as well. So if I come over and click on the tab here to go back to the 2D view, if I click on and check the box next to the toolpath, then it becomes visible, and now I can see that drawn in the 2D view. And the default way that this will draw, as long as I have show 2D previews checked down the bottom right hand corner here, is just a line showing the toolpath there. So if I click in the 2D view and just zoom in, you can see that this kind of reddish line coming around the outside, the arrow showing the direction, and the green square showing the start point for that toolpath. Now, as well as this view, I can check the box for the solid view, and what that shows me is a shaded area that represents the material that's going to be cut by that tool. And if I zoom in nice and close here, I can see that that's slightly overlapping the line, and the reason that's overlapping is because we set that negative allowance. So this is showing me how the part will be slightly overcut so that the outside of it will get slightly smaller, the inside shapes here will get slightly larger, and that's just going to give me that difference to allow the part to be slotted together. So let's just click in the 2D view and hit F in order to fit that back into the window there. We can close the preview toolpath form, and at this stage I may actually want to save this toolpath out as is. So to do that, I would just have the toolpath selected, I would click on Save Toolpaths, and then from here I would choose the appropriate post processor, whatever made sense for my particular machine, and I would click on the Save Toolpaths button there, give that a name, and this is a file I could run on the CNC. Now in this case, if I was to cut this toolpath exactly as is, I'd need to make sure I had a way of holding the part down, because we've added no tabs or anything here, so I'd need to make sure I had some kind of vacuum hold down or another method for holding the parts in place when we cut them out. In addition, there's some other things I might want to change about this now rather than just go ahead and cut it as is. So what I'd like to do is just take a few minutes to look at some of the alternate options that we might have to approach this part and show you some of the other different ways that we could set up the toolpaths. So let's just close that now. We're not going to save any toolpaths at the moment. So once you've calculated a toolpath, it's always worth having a look at it and just seeing if there's anything you can do to improve it. Now in this case, I can see a few different things that I might want to change here. First of all, these parts are quite close together. I mean, we've been quite generous with the spacing on this, but it may be that I just want to select the vectors here, so I click and drag to select those vectors there, click on them again to go into transform mode, and just holding the shift key down, I'm just going to click and drag those over to the left a little there to increase the space that we've got between them. And at this stage, to recalculate the toolpath would be as simple as selecting it, double clicking on it, coming down to the base of the form and hitting calculate again. If we reset the preview and preview the selected toolpath, we can see what the new version of that will look like, and we can increase the speed there by pulling the slider up. So now we've added a bit more spacing in between here. So that's one easy and quick change we can make to that toolpath. In addition, there's some other things I'd like to do here. For instance, as we cut these areas out here, I'm going to end up with some very small bits of material. Even if I have a vacuum hold down, it may not be enough to hold parts down as small as this. I don't want to really put tabs in there because I'm going to have to then cut those out manually and clean those areas up. So in this case, it would probably be worth me taking a little bit of extra time to pocket those out so that there's no material left in there and I don't have to worry about holding those small bits of material down. The other benefit of that in this case is I could go ahead and add my negative allowance on these to oversize just these holes for the assembly part of it without having to then undersize the rest of the part when we do the profile. So let's go ahead and set that toolpath up now. I'm just going to close the preview toolpaths form. We'll come over to the 2D view and I'm just going to click in the white space to deselect the vectors. Next, I'm going to select just the inside slots. So I'm going to click and drag and completely enclose this set here. So they're selected. And then holding the shift key down, I'm going to do the same over here, making sure that I don't completely enclose that kind of cog shape piece. So I only want to completely enclose the pieces inside there, dragging from the left down to the right. So now with those vectors selected that you can see, I'm going to come over, click on the pocket toolpath rather than the profile, start depth 0, cut depth Z equals, I want to go all the way through. I'm going to hit select, choose the 1/4 inch end mill, hit OK, and then edit that in order to change the pass depth there and some of these other values in order to be able to potentially use the same tool if I want. I'm going to set this to raster to cut that area out, and what we want to do here is switch on the advanced options for the pocket toolpath, because I do want to add this pocket allowance. Remember, we want to oversize these slightly, so when we're doing a pocket like this, it's still going to be a negative allowance, so I'm going to put negative 0.02, and we'll call that pocket cutout slots and hit calculate. I'm going to reset the preview at this point in time. I'm going to move that up in the order in the toolpath list, so I'm going to select it and hit the up arrow there so that we cut that first, and with that selected I'm going to click preview selected toolpath, and you can see that's going to completely machine those areas away. If we want to look in the 2D view, switch on the visibility for that and then zoom in, we can see again that we're pocketing those with the negative allowance. They're all going to be slightly overcut, and hopefully that would be enough to allow these parts to slot in. And again, if you wanted to, you could cut a test piece first in order to check out to see what kind of value you might need to leave. So if the pocket toolpath looks okay, we can go ahead and close the preview toolpath form. And now what I want to do is edit my profile cutout toolpath. So I'm going to select that, and as you saw before, I could double click on it to edit it, or we could come up to this icon here to edit the toolpath. So if we click on that, you can see it's going to open the toolpath form again, and it's showing me the original set of vectors that were selected for that particular toolpath. Now in this case, I no longer want to cut the internal vectors because I've already pocketed those out. So I'm just going to click in the white space to deselect everything, and then I'm going to hold the shift key down and just click on these 5 vectors here. So coming over to the toolpath form, start depth and cut depth will remain the same, as will our tool selection. But sometimes we might want to override the depths of cut the software is calculated based on the pass depth setting for the tool. To do that, I can click on the Edit Passes button here and the various other ways that I can control these depths of cut. At the top of the form, I have the ability to manually override any of the values that are already there. For instance, we can select the first value here, and maybe I might want to make this a little bit deeper, perhaps to ensure that the breakpoint of a compression cutter is getting below the surface of the material. So we could come in here, enter a value of 0.27, hit apply, and you can see that's been changed here in the pass steps form. Further down the form, we have other ways that we can control this. For instance, if we wanted to make the last pass a very light one, we could set a last pass thickness, enter a value here, typically a fairly small value. The software will ensure that there is that thin skin of material left, and that's all that needs to be cleaned out as the tool makes its way round the last pass of the toolpath. Another option we have is to maintain the exact toolpath depth. What this will do is ensure that every pass is whatever you've set to be the pass depth of the tool. If you don't check that, then the software is just going to divide the thickness of the block up until it gets to an equal value which is less than the pass depth that you've set. So if the pass depth is very important, again potentially for something like a compression cutter, you may want to look at checking that box there. Another way of setting the pass depth is just by specifying a number here and hitting set passes, and again that will just divide up the block by that number of passes. In this case I'm happy with the settings we've got here, so we'll hit the OK button. Next we come down the form. I do want to maintain cutting outside the shapes. I'm going to remove the allowance offset now and set that back to 0, and that's because I've specified the allowance on these pocketed areas, and I believe with this particular design that should be enough in order to allow the parts to assemble. Now coming further down, we've got this option to use vector start points. What this does is allow us to be very specific about where the tool is going to enter onto our part. Now at the moment, if we check that, you can see the software will show me green dots on our job, and each of those indicates the start point for the particular profile pass. Now if we want to change these, we'll actually need to go in and make edits to the vectors themselves. So let me show you how we would do that. So we'll come into the 2D view and we'll click to deselect the vectors, and then one at a time we need to select them, and you can see the start point currently of the vector there. I'm going to hit N on the keyboard to go into node editing mode, and now what I can do is select the place where I want the start of my toolpath to be. So in this case it might benefit me to start up here, so I'm going to grab this midpoint, right mouse click, go insert a point, and then right mouse click over that point and tell the software to make start point, and you can see that's now become green. And I can work my way through and do that on any of the other parts. So select it, right mouse click, insert a point, right mouse click, make start point. On this vector here I'm going to do it with the midpoint of the arc, insert a point and right mouse click to make start point. And also I can do this with shortcut keys. So if I select this here, I can grab that there, come over it and hit I to insert a point, and then P in order to make it a start point. Select this last vector here, and then we'll do the same here, I to insert a point, P to make that the start point. Now if I hit escape on the keyboard to go out of node editing mode and I reselect my vectors, you can see the software is displaying each of those points that I've just edited now as the start points, because I have this use vector start points option checked. So I'm happy that I'm getting really good control over this toolpath with my pass steps and with my start points. Coming down, the next option we get to is this last pass option here. If we do a separate last pass, what the software will do is it will stay away from the finished edge of the part by whatever distance we specify in the allowance here, and then the final pass will just step in by that value, so that effectively the last pass that we make is going to cut around the part full depth of the tool and in theory give us a very clean edge. So if we want to do that, we can check the box here, we can put in a value. So if I put in a value of 0.03, what the software will do, as I said before, is stay away from the edge of the part by 0.03 of an inch until the last pass, when it will step in that small amount and clean up completely full depth of cut around the part. If I want, I can also reverse the direction on that last pass from whatever I have set here between the climb and conventional. In this case I'm not going to check that box. The next section of the toolpath form gives me more options to control different parts of my profiling. Have tabs, leads, ramps, the order of the toolpath, and whether we want to add sharp corners to it or not. In this case, what I would like to add is some leads. What the leads will do is allow the tool to come down away from the edge of the part and then lead into it, go around, and if I want to then lead out as well. What this will allow me to do is to reduce the potential for a dwell mark of the tool plunging down directly next to my finished surface. So if we check the box to add leads, in this case I can do a straight line lead or I can do a circular lead. So I'm going to do these sort of circular arced leads. We'll go with a radius of 1, a lead length of 1 in this case, and I'm going to also choose the option to do a lead out here. So that means that it will lead in, go around the part, and then lead out again. So again, just reducing the chance of a dwell mark as the tool retracts. I can also set an overcut distance, and that means a distance between the lead in and lead out that the tool will go past the original position, again just to try and reduce that chance of leaving a mark. So we'll set our overcut distance here to 1/4 of an inch. In fact, let's make that a little bigger. We'll set it to be 1/2 inch there. Scroll down to the bottom of the form and we'll go ahead and hit calculate and see what that gives us. Now if we take a look at the preview there, we can see we've got these leads and we can see that they all occur where we set those start points to be. So you can observe there the control that we've started to get over the toolpath by making some of these changes. Now in addition, if we look closely, we may be able to see the fact that the first two passes, as you can see here, are slightly further away from the edge of the part than the last pass. So it's going to come round a little bit off the part for the first two passes, then the last pass will step in and clean this out completely. So that's the effect of that last pass allowance option that we checked there as well. So we can take a look at this if we want now. Let's just go into the ISO view there. We'll preview the selected toolpath and we can see how that's going to look when it cuts that part out. Main thing we're really going to see here is the lead in. The other things won't be particularly observable, but we should see the benefit of those on the actual final cut part. Again here I'm assuming that I have a way to hold the parts down without using tabs. So we're going to assume that we've got some kind of vacuum hold down or another method that we can hold the parts in place here. If I want, as I've done this cutout completely through the material without tabs, we can double click on the waste material and get rid of that in order to see each of the finished parts that we're going to get after running our two toolpaths there. So we've seen a couple of different things in this example here. First, you saw how quick and easy it would be to calculate a simple profile toolpath around the parts to cut them out. But then secondly, you've seen how, if we want to, we can gain a lot more control over that toolpath to change the way that it's going to machine. Now the last thing I'd like to show you here is how we could also affect the order that the parts are cut out as well. At the moment, the software is just calculating these based on whatever our default settings are in the form. But if we wanted to, we could very precisely change that order. So let's go ahead and do that. If we just close the preview toolpaths form, I'm going to select the profile cutout, click on the edit toolpaths button again, and I'm going to come back into the 2D view. Now if we come down to the order part of the profile toolpaths form, you can see that there are various different choices we can make here. We can choose different options that the software will just use to do its best to satisfy those parameters to cut the parts out. Or if you want complete control, we can uncheck these. We can choose vector selection order, and we can actually click in the 2D view to deselect the vectors, and then we could come and pick the order that we'd like to see these getting cut out. So perhaps I'd like to start furthest away from my datum. So if I select this one first, shift and select this one, then this one third, this one fourth, and this one fifth. And now with the vector selection order box checked there, if we hit calculate, that's the order that it's going to cut these out. I can see it going across to here, then to here, to here, to here, and finally to here. If we want to see a more visual representation of that, I could reset the preview, I could slow this right down, and I could say preview selected toolpath. There it's showing me that it's cutting out the first shape, then it's showing me the second shape that it's going to cut, the third shape that it's going to cut, fourth, and then fifth. And we can speed that up if we want as we work our way through. So there you can see it's possible for me to control almost all aspects I want of parts when I'm cutting them out, to really do it in whatever way is most appropriate for the particular job I'm doing. In this case, of course, we would have used the pocket toolpath first. If we want to see that, we could reset the preview. I could uncheck animate preview to speed this up and just say preview all toolpaths, and there we can see the finished result again. And if we're happy with that, we could hit close, and now we can actually output those toolpaths to the machine either individually or by checking them both, clicking the save and checking the option to output all visible toolpaths to one file. I can output them into a single file that I could send over to my machine and run. In this case, I'm not going to save the toolpath, so we'll just close that, but I am going to save the file. So we'll come up to File, Save As, and we'll just change the name of this file. And in the project folder, we'll just call that Three-Legged Stool Toolpath. Go ahead and hit the Save button, and if you want to, you could open that up and take a look at it in the state that you see it in the video here. And at this stage, that actually concludes our tutorial.